to be live. Yeah. Let's see. Well, hey, did you get a notification that it started? Yeah. Well, I'm glad it's willing to make noise for the start of this thing. So with that, I'll go ahead and mash that key, and yeah, so we're going to talk about SQL and databases. So this is no, is that me talking? I'm picking up that. I heard myself talking for a second there. Yeah. All right. Cool. So definitely not going to give my presentation to you because that's not what's really necessary. I mean, especially because tomorrow I'm not going through all of it, just a little bit, but more curious on just what your current situation is with SQL, and I can kind of work from there maybe. Mm-hmm. Mm-hmm. Yeah, a bit of a different realm. Okay. Oh, well then let's go ahead and do that. So we can answer your SQL questions. It may take a little bit of work because I need maybe an example database to do it, but let's start with that then. So I already have a database created. I got the Postgres.app, and I created a Postgres 10 server. There's nothing in it right now, and I was able to test that I can connect to the thing. If you want to tinker with Postgres, that's definitely something I recommend if you're on a Mac, just because it makes life easy. Is if you just go and look up like Postgres.app, but don't actually type in that URL because it's a real URL, so you have to like Google for it, and then it'll show up in here, and then you can, because .app is actually a TLD now, so it's not something you can just directly search for. You have to, yeah. But you can go and grab that, and it just sits in your task or in your icons list, and you can go and like create a Postgres server, and it lets you go and grab on or open up whatever, or like create a new server. Like you can say I want this Postgres version, and it just does it, and you don't have to do any other screwy things. Yep. That I don't see a way. Maybe there's a way that they could take donations or something. It says it's maintained by these people, but yeah, they do a good service to the community. Thank you, Jacob Edgar and Chris Pastel and Matt Thompson for your efforts on that front. So anyways, I set up with that. I have nothing in my database other than just like I created a brand new one called SQL Sample. So let's go ahead and get a sample database that is actually made by Microsoft called Chinook Sample Database. And I think this La Rocha is the right place for it. And it is this sample database that holds a whole bunch of information for a bunch of different database servers, which is kind of nice. So that way you can test the same thing against a few different platforms. And I mean, music is kind of the main thing, and there's music, there's customers, and there are like invoices and I don't know, kind of common businessy things. So like both music tracks and the like sales side of it. Yeah. I realized that I didn't actually double check. Is my actual screen showing? Okay. That's good, because I was kind of reckless and just made sure that the stream starting thing was showing up, so glad that it's all there. Alright. Okay, so how do I download and get that? So if I go to this downloads page, then there should be a Postgres one in here. And it's just a big SQL file. And let's see it raw. And we'll go and copy the whole thing. Maybe. And then inside of SQL tabs, I'll just post that deal. And of course it died. Oh no. There's too many invoice lines. Alright. Well, in that case, what I will do is I will go and let's see. I'm gonna go ahead and download the file instead, so I'll just like save the thing and so Chinook PostgreSQL and put it as Chinook PostgreSQL, sure. And then if I open up my Postgres options, I think from here it actually will go and start up iTerm. I think. So I open up SQL Sample. There's like a way to do it. Maybe Tmux will let me do it. So if I go ahead and I do pSQL, that puts me in the JState, and so pSQL, and then sample. If I do pSQL SQL sample, that puts me into that database. So if I do pSQL SQL sample, and then I pipe in this like downloads slash Chinook PostgreSQL txt into it. Does that work? Give me a whole bunch of invalid things, but insert or update violates foreign key constraint. Okay, so it may not have liked everything that happened in there, but I may have some stuff in the database. So let's go back to my SQL tabs, and if I go ahead and do select splat from artist and execute that, I don't know, artist. All right. we're gonna go here. We're gonna go to database info, and that will let me see what's in this database. Oh, it's, wait. What? Yeah. Relation artist does not exist. Does it really need to have... Oh, that's gonna drive me nuts. But... Yep, because Postgres likes to lowercase things, so... we'll take it, I guess. I'll roll with it for now. But that would make sense why it was an add. So just so you know, Adam, that when I'm running that it will downcase it. But if the table is capitalized, you need to you need to double quote it, because double quote is the way that you indicate that you are referring to like some object or some like almost a variable like thing within Postgres. Same for like column. If you wanted to select name, which does that mean I have to do this too? Oh no. Alright. Well, why not, right? It's very proper. But yeah. As for like renaming all those things, I'm not gonna deal with that. That's a good thing to know with this though. I think SQLite is more lax in it, and it doesn't force you to go and capitalize everything. But here, Postgres is making us do just that. So, all right. So we've got a whole bunch of tables, as you kind of started to see in the database info. If I go to this public schema, we have a whole bunch of tables in here. We've got albums and artists, and albums happen to have tracks on them. And there are customers and employees and all those things. Like, we got a lot of stuff in there that is nice for us to work with. So let's see if we can find something that would maybe let us do an outer join, so you can see that in action. So if I do, let's go ahead and run select splat from artist join album on this is gonna yeah, gonna alias, so I don't have to do it all over. R dot artist ID equal. Oh no. Do I have to? Will this work? I don't know. I don't know where I have to put the quotes. Does that work? Probably not. Okay. Is that? No, that's the way. Ooh, this is, yeah. So, lesson to you, Adam. Don't go and name your tables with capitalized things, because it will. You'll pay for it. So, if I do select splat, or if I do even just like select count from that and run it, then I've got 216 artists when I join them with albums. What if I just run select count from album, and then I have to put that. Okay, so there are 306 albums. So 244. All right. Oh, and then also this is really bad. Album ID. Or I did it again. So I need to line them up on artist ID aligning. So there we go. So yes. So every album happens to have an artist. Yep. And our database may be constrained on that front. But yeah. So we can go ahead and we can answer that question, that if like there are any artists that don't have an album, because that would be kind of interesting, because then we would yeah, that may actually be, there may be a foreign key constraint on that, like, so we can check on that if there is a foreign key constraint to say that every album has to have an artist ID, because that seems like it would be a reasonable one to make. You familiar with a foreign key constraint? Okay. So, let's see. Next, foreign key. So it says there is an index foreign key on album artist ID. So saying that like there is going to be a foreign key constraint that we can't insert an album without a corresponding artist. So if I were to go and say insert into album, and I wanted to give it a album, I'm gonna give it everything. So values, and if I were to give it the values of an album ID of, I don't know, 5,000, because we don't have that many albums in our database, a title of best songs, and then I mean, it's showing an integer there, so I mean, I can see if it auto inserts an integer, but looking at the schema of it, it says album. Here it happens to be an integer, not null. If you want something in Postgres to be auto-incrementing, then you would want to have an album ID of type serial, and serial will go and increment the ID for you. But if we don't do it, then no. So we're gonna just insert a new album with our new ID and call it best songs. And we're going to give it an artist ID that we know doesn't exist because we don't have any artists with that. I mean, I can double check, but do you trust me on this, Adam? Okay. So if we try and do that, then we'll get back this album violates foreign key constraint FK album artist ID. So we can't insert an album that doesn't have an artist. But I'm sure we could insert an artist that doesn't have an album, because you have to be able to have the relationship. That wouldn't work any other way. Right. So let's see. If we want to answer the question of how many artists don't have any albums, if we were to go and say we want to select from artist, select from artist, let's see, count, splat, artist, AR. Alright. And we're gonna join our album table. And we will join it on AL on AR dot artist ID is equal to our album's artist ID. So we go back to this query again, which gives us our count of everything. And then if we say we want to group by my artist dot artist ID, then by doing that, we're going to have a whole bunch of counts there. So there's one for every artist ID, which there only is 176 rows, which is kind of telling that we have artists that don't actually have any albums. Because if you remember, our artist count was a lot higher than that. I think if we do select count from artist again, we run that and we run both of those. So there's 244 artists, and right now we're getting back only 176 rows when we're grouping by artists. So that would be kind of indicative that we have artists that don't have an album. And if we actually want to find those things, that is where a left outer join comes in. So right now with a join, we're only selecting artists that happen to have an album. Like by default, like an inner join says, only show me rows from the tables that are getting joined together that match or meet this condition. Condition being that the artist artist ID equals the album's artist ID. And so that's discarding any artists that are unknown. Yes. So by default, joins are inner joins. Like this is equivalent. The difference is that because they're so common, SQL just makes them the default. Right. Yeah. So now that we have this, we can say, all right, well, I actually do want all the artists, even if they have a count of 0. So let's first go ahead and do this as we'll call it as, I don't know, total or something, because we can do order by total, just so we can have them nice and ordered. So the top things in the list happen to have a total of 1. We should probably start seeing some with a total of 0 when we get this thing right. So and ascending is default. So we're getting 1 here, which is what we expect to see, which most of our artists seem to have that. And then some of them go up and up to 2, 3, and 4, and so forth. So now if we change this join to a left join, which is short for left outer join, and we run that, now we're getting 244 rows. And I don't know why we're getting still 1. Maybe I'm screwing something up here. Because it should... Why is there not a 0 in here? Because now we're getting everything, whereas we weren't before. Hang on. I'm not going to do any more group bys. Let's see if that gets us then. So if we stop grouping by, and we select artist dot everything off of artist, we can see all of our artists showing up here. If we say where album dot title is null, then we can see and because I guess if we select everything, that might make it a little more obvious. Oh, I can't do splat. Okay. So we can see all of these artists in our database, like Santana featuring Eagle Eye Cherry, they don't actually happen to have an album. So that is what the left or right outer join will show to us. The difference with this is working right here. The group so the left outer join, yes, it will include both. So it doesn't just filter to that. So that's where the where is null comes in. Because if I had this left join right there without the where, if that were commented out, we could see a combination for every artist and every album that they wrote. So we can see except has balls to the wall and restless and wild. And within this, yeah, there will be something in here. There we go. Yeah. So, yep, not in our database. Yeah. So that is kind of the difference. And also for the inverting of a left outer join, there's also a right outer join, which that will get you. Yeah, it. But as far as I understand, though, like tracks themselves in this database don't actually have an individual artist. So I guess I can see, like, if I go ahead and sure, I'll comment this deal out for a moment. And if I do select splat from track, not track ID, just track, and limit 20, sure. Yep. So tracks happen to have an album ID, and they have composers, but they don't actually have which artist. So, right. Yeah, we don't care about composers elsewhere in our database. Like going in the fact that, like, well, yeah, composers, they're just ignored. They're overshadowed by the artists that are making it, I guess. At least in. Yeah. Especially because, like, they happen to be just comma separated. So you would have to go and, like, split these things up by comma. Which, right. So yeah, that is a difficult question to answer, Adam. I don't know. I did not make this database. And in like every production database, there are some ugly parts. Yeah. Maybe. That would be an interesting middle name to have. Jason and Staten. Yeah, I guess your name itself, like, you could use as like a hip startup or something. Like I feel like so many startup names have like an and in them. Like when they're trying to be crafty or like yeah, like this place that I may go to in Portland in a little while, Tasty and Alders. Like, yeah. And there was another one that was like, it's an ice cream place that is Salt and Straw or something like that. But someday you have to make it. Yeah. All right. So that, does that help answer your left outer or outer join versus inner? Okay. Where it only gets the things that don't have a match. So there is, what is it, a full join, which will, like, do you want just one side with no match? And so that's where you do the is null type thing. So the join itself won't go and filter that out. So the full join does both things. So it will get both sides of the table. So you can't see it here, but if there were any albums that didn't have an artist, a full join would get you that as well. Correct, because of our foreign key constraint. Yes. Yeah, so it will put at least one row in for both tables if there's no corresponding match in. Like it'll put an artist in that has no album information, and it'll put an album in that has no artist information. Okay. Cool. Let's see. Let me hit up my slides real quick. So talk about databases and how they come in a whole bunch of different forms, and you store them on paper and blah blah blah. All right. So talk to joins. All right. So group by. Are you familiar with group by? And we just did one. Okay. So, yeah. So like I had this example of doing group by. So like, I asked students like, how many customers does each country have? So the way that I can do that is first I want to, I'm asking about customers, right? So a good starting point is just select SWAT from customer. And I run that. And here I have a whole bunch of customers. But yeah. Yep, so group by country. I run that and it yells at me because I need to do this. I am really glad that I'm not actually doing this in Postgres with them. All right. So now, yep. Yep. Yeah, so this is a long form way of saying I'm trying to select all my columns, and customer.customer ID is not inside of an aggregate function, and it's not inside of the group by. So it yeah. Right. Yeah, only country is acceptable here. Yep. But here we can go ahead and do a count of SWAT. And that will get us all of our counts. Look at that. I actually, this one I have them work through inside of Chinook. So sidetrack. I call it Chinook. I guess we're working with Chinook. So I made a web tool called Chinook.ml. We talked about it on the latest Web of Tomorrow, actually. Yeah, I listened to it today. I liked it. Came through good. Nice editing on it. So, yeah, this Chinook.ml tool is a way to let you write SQL right inside the browser. And it is SQLite compiled down to JavaScript with like mscripten or something, because SQLite is written in C, but mscripten will let you run that inside of the browser. And then I just took like CodeMeter here and a Chinook database that I stripped out a lot of the invoice lines because there are a ton of invoice lines in the database, and it was way more than I wanted to make you download. I think I got the download size down to like 2 megs or something. So it's a size of like big enough database, but it doesn't have every invoice line. So anyways, I have them do it in here, and SQLite actually doesn't error out. I really wish that it did, but it doesn't. And yeah, and instead it's like undefined behavior that you get back. So if you do a like select SWAT from customer group by country like that, and you run it, it will give you stuff, which is really unfortunate because everything in here other than country is totally random. Or I guess not. I guess I wouldn't call it random, but undefined behavior. Like right. Especially because, yeah. What's really confusing is when they go and wind up in the case of, like, let's say, I don't know, we wanted to do a, like, select, like, max of, if there's like a good numeric thing here. Sure, support rep ID or something. So if they're doing that, oh no, I hit Command R because it's the same thing. So select max. So I hit Command R, so undo doesn't work across. Yes, because in SQL tabs it's Command R to execute a command. Yeah. Yes, and flip-flopping between them, I'm bound to get burned. So either way, so there's like select max support rep ID, and I think there's like first name, last name, like that. So like if we get Luis Rojas, like we get this max support rep ID. This is wrong, because if you're doing an aggregate, you should not be able to go and select other columns, because the fact that Luis Rojas is here is just kind of arbitrary. And I try and prove the point to him by saying, like, by giving average, because I'm like, okay, Puja, oh man, Shrivastava, yeah. Well, anyways, that person does not have a support rep ID of this. Like, nobody has a support rep ID of that. We know for sure. And so that's like my way of explaining to them that you can't go and rely on these things. Yes. So, and then it is correct. But like here, what's nice about Postgres is when I do run that, then, first I have to quote everything because support. Yes. I wonder if there's a way to like turn that off. I don't know. Last name. And then I'll just ignore first name, sure. But anyways, if I go and execute that, then it'll actually yell and say the same error that we saw before, where customer last name must appear in a group by clause or be used within an aggregate function. So Postgres is nice and helpful to tell you what to do. Yeah, right. So good job, Postgres, for not deceiving users. So that is one hurdle that I have to tackle when teaching with SQLite, is that it's very loose in what it accepts, which is all right, because I mean its purpose is to be embeddable and really fast, and so they cut some corners on it. Like, they don't have right outer joins, instead they only have left outer joins, and right or left. But yeah. So that's just one thing that is a slight difference that I try and bring up, but I also try not to spend way too much time on. But I am like, just so you know, if you're using SQLite, this is not right, and here's why. So the average is a good example as to why. So here, if we go ahead and we select our counts from customer, group by country, so we're getting at these counts. And from here, I'll work through and say, all right, so we have these counts, but how do we know like which countries these pertain to? Because, I mean, it's great that I have 11 different counts, but why does that matter? And yep, so country, yeah. So country is totally acceptable. And in here, I can change up or like order these things, because my question was like, which country has the most customers, right? So I can answer that by using an order by. And when you think most, you should always like you should be thinking in the mindset of some sort of order. Like most is indicative of a comparison. So if I were to say order by count of SWAT, and then I execute that, now I've got Italy showing up, but I want it in the other order, and that's where I pull out descending, or use descending, and that gives us, yep. And then right now we're selecting everything, and in other databases, yeah, because, well, right here we're only getting 11 rows. Like if we had every country and we only cared about the first one, this would be kind of wasteful. So when you say most, you can think order by plus a limit of 1, and that will get us our USA. A max on count. Yeah. There is a max, but what column do we want to max over? I mean, I guess you could get... Yeah. Hi. Oh, to get like the country that has the max of that. Oh, so like select max of, I'll name this thing there so I can see that. All right, so count as I didn't know if it would accept that, because I know sometimes it'll like put the formula right there. I'll call it C, because why not? Shorthand is good. All right, from, so if I select max from that and then execute it, then subquery in from must have an alias. Yep, as other. All right. Oh, to go and do this? No, it's gonna give me that same error that we were running into here before. Yeah. So, we're kind of back in the same place we were at before. Oh. Group by country. Yep. And so we're it's getting the max for each country. So once we start grouping by the country, right? So yeah, well, we have the same numbers that we had before, and we can. Yeah. This is not good at all. Here we are. With a pretty wasteful inner right there. This is what I will try and demonstrate to the students. So you can write terrible Syriac. Yeah. Okay. So there is something else we could do. that I am curious about. That we can back this up. That is not something I'll show to them, but I will show it to you. That so let's see. Do I have to? So if I do the country, see as count. If I do, what is it? Rank. So let's go ahead and Postgres rank. So we might be able to pull it off with this. So with some window functions. And let's see. Rank at the current row with gaps. Same as row number. Let's see. How to rank in Postgres query. Let's see this in Stack Overflow. Rank over. There we go. I always forget the syntax for it. But yeah, ranks are kind of cool, so order by C? Order by. Yeah, it is. Alright, so if I run that, C does not exist, so I can't do that yet. Because I'm selecting by it. Alright. Okay. So now I get rid of this order by right here. And now I can see so if I do that, now I can say where rank is equal to 1. Oh wait, I gotta swap this around, hang on. Can I do that? Wait. Does this work? Rank does not exist. As R. 1? Can I do that? R does not exist. Can I not do it there? Do I have to do having R equals 1? Yes. We're going to talk about having next, but column R does not exist. Well, I mean, it seems to, right? I don't know why I can't do that unless ranks are. Oh. It's probably just the order that Postgres is returning it back to me, because it may be most. Yeah. Well, I mean, we need to rank over something. Alright, here we go. Here's your nested select again, alright? So if we select Splat from this whole deal, and say as, I don't know, other, there are equal to 1. Aha! There we go. No, there's no limit for you. Yeah. Yeah, I'm kind of interested by like what it takes to go and select off of that. I think you can. I think you can go and check too. With as other select from other. What is it called? Wait. Other as? Like that? I'm trying to remember. Because there's also like the common table expression. Select from other. Oh, I want to select everything from other. But tell it to select nothing. There, we can do that too. That can pretty it up a little bit. And it's not quite so nested looking. So this is the common table expression. So it lets you, yes, sometimes called CTEs. Yes, I guess it's so it's part of the same query. So like if I were to go and do this, then that would not work. Like with needs to be part of the like preceding query or query that comes after it. So it does need to be there, but it like a common table expression will let you go and like specify a select statement and then reference it just as a table there. And it's you can't use the word temporary table because temporary tables also have a meaning inside of SQL. So a temporary table, if you ever did like SQL Server, they're like tables that I think they have like a whatever hash sign, octothorpe, pound sign, that thing above 3. They have those in front of the name usually, and they are. There was a 99% invisible about it recently, because they talked about the interrobang, and then they were like, it's one that has barely been used, but one that is overused now that you are probably tired of is this symbol. And then they talk about hashtag octothorpe. I think octothorpe was like the earliest meaning, and like they talked about how it wound up on the phone and stuff. Oh, so just like this. Hey, look at that. Then common table expressions. Yeah, that would make sense. I mean, I guess one kind of cool thing about this, like using the rank, is that you can find things that are also tied. Because if you noticed in our query after doing this, that all of these that are rank 6 all share that same rank 6. So you can actually you should be able to. Like if there's a tie, then you'd probably say like order by count descending, and then I don't know, like country or something. Let's see. There we go. So now everything has an individualized rank. So Australia winds up being first amongst the ones with a count of 1 because of the tiebreaker country right here. But I guess that is one perk that you can get from using a rank that a limit wouldn't get for you, is that like if you wanted this case where like multiple things, especially if something tied for first, you'd actually know what that was. Yeah. So ranks and window functions, I don't really use them, but they are useful in some scenarios, and you can get by without using a limit. Instead, you can do something else. So there you go, Adam. All right, so we had talked about having. So let's go ahead and backtrack a little bit from all this. So we'll get rid of our ranking, which ranking is not stuff that I bring up with students, given it's like their 3rd day of writing SQL. I've considered doing it in an advanced course though, like saying, hey, by the way, there's this other thing that you might want to use for some scenarios. So Anyways, if I select this, now I wanted to find out first which country had the most, which was order by C descending, which gets me that, and then limit 1. So we're back to our USA being number 1. Good on us. And then in here we have how many customers does each country have, and we have which country has the most customers. And then finally we're asked, okay, well, we don't want to just do the US, so which countries have at least 5 customers? And so here we can look at the data, and like your initial desire might be to do like where C is greater than 5, right? And you do that, and right, because where's happen on each individual row, and what we want to do is actually ask where C is greater than 5 when after we've aggregated. So that yeah. And I don't know if the reason being is that it could cause something ambiguous. Like, I don't know the specific scenario, but maybe there's a case where you're like, if you have a where filter, then it's ambiguous in terms of what it means. And so if we go and I don't know, maybe that's why they have having. Maybe it's just so the reader knows. I don't know why they chose it, but that's what having is for, where you can say having C is greater than or equal to 5, and then if we run that, then it's telling me column C still doesn't exist, and I'm confused. What? It doesn't. Is C not available? Greater than or equal to 5. Apparently that alias isn't available at that point in Postgres. Right, then it'll say like misuse or something like that of aggregate functions are not allowed anywhere. So they're very explicit on it. Don't do this. It's kind of interesting that aliases are not available within the having. But I guess that is database dependent, because I think SQLite actually is cool with that. So if I copy it, yeah, I mean, SQLite's good with anything, right? So if I put this thing here and I run that, and I have that, but if I say like having C greater than or equal to 5, then I still am getting the same result if I run it. So it will actually yell at you as well. So it's not like SQLite doesn't entirely give it up. It just yeah. This one tells you misuse of aggregate. So I guess it, like, Postgres is very blunt and to the point. This makes you think about what I mean, I think I'm using it right. Oh. Yeah. I don't know. Difference in implementation choices, I guess. So that's having. And then if you wanted to take it a step further and say, okay, well, we want to have that sale. We want to have it for those countries. And then you're prompted with the question of which albums have earned more than $20. So that way we know which ones we really want to put on sale, because we want to put our top sellers on sale or something. And that one I don't actually have them work through, but rather I give this lovely example query where we go and we go and find all, or we group our tracks by their album IDs, because we're concerned about album IDs, and they get the sum of every invoice line for a given track, and we multiply the unit price by the quantity, because apparently you can buy the same track multiple times. And I guess you could want to do that, maybe licensing or something, but either way, you multiply that sum and you say, is that greater than 20? And if it is, then we get album IDs back, and in that case we could go and get the title. I try and do that in my slides to make it obvious, like, what are our SQL keywords. So there's it's kind of convention to go and do that when you have formalized your SQL a little bit more, just to say this is a SQL keyword, this is a SQL keyword, but nothing other than that. That would probably make sense, especially I mean, I don't do it in all cases, but this is a pretty big place to do it, so that's a good thing to call out. So I can, yeah, but I also see it as probably a valuable thing. I mean, most cases, there's not near this much. It's usually a quick one-liner. And also, I actually don't spend a lot of time on this. I used to spend more on it, but then I also figured this is just a big blob and confusing. It's way too much code to be showing them all at once without constructing it in front of them. But I don't want to take the time to do it. So a lot of times I'll say group bys give you a lot of power. Here's an example of it. Go check the slides. And then I kind of move on, because all it does is gets blank stares. I should probably just pull it from the slides, honestly, but it's also an example of a more complex query. Yeah. You don't, because it's inside of an in. If I were using it for a from, then you would have to. Yeah. And I would test it in Postgres, but I don't want to put quotes around everything. And let's see. So I talked to him about yeah. Well, what's that? Yeah, just shows what we're moving on to, I guess. But I see what you're saying. There's some value in saying you did it. You created rows and tables. Yeah. Is this invisible to somebody? That is something I haven't actually tried, but just this, is this problematic? Yeah, what does it actually look like to some? Yeah, well, I mean, this is it's the same color palette, so I'm less worried about it being a bright red and scary, because it's usually something I don't spend a lot of time on. I'm just updates, and then, but more so can somebody who is colorblind Mm-hmm. Mm-hmm. Yeah, where they have like all those circles. Yeah. Yes. Yeah. Just you. But, it's all right. I guess I'll investigate that another day. But talk about updating a table, and this is something that students are always kind of itching to do because they're like, you make changes, and so alter table. So this is something that you haven't seen or I haven't showed to you, so it's not familiar. But to them, one sample database that I work with is this injuries table, which injuries are they're a thing that can happen to you, and they have a few things. I will show you in the SQL course stuff, so you can see that. So when we're building up our initial database, we create this new one that is called injuries, and it's got an ID, name, description, and time to heal. And actually, it's named TDH as a poor example because you don't really know what TTH mean. Like, if you were a new developer and you just saw TDH in there, you'd say, "What is this thing?" Right. And even if you know it's time to heal, like you don't know what unit it's in. So it's like all around like a bad example, but it's kind of intentionally left there. If that makes. Yeah, so it's. Sure. Yeah, like I don't know if they would actually use the term, but we could call it specific to our domain. That's like, because it's just a column name, so it's not a programming thing. But either way, it's a confusing name because there's no mentioning of units in it and like what it even means. Like you'd have to go and kind of, yeah. So bring up to them that it'd be much better to go and name it something like weeks to heal, because that's what it is. Because if you saw weeks to heal, yeah, it's longer to type, but it's way clearer. Right, like if it's like referring to days or right. But anyways, our injuries table have these things. So we have like pulled groin, cervical radiculopathy, herniated disc, and various others like Nintendo thumb. And anyways, with those, like let's say we wanted to go and add a pain level to the table, we would do it using this, and then I'll actually like normally walk through going and creating that. And something that's not covered well here in the slides, but I do bring up with them, is the ability to go and do something like a default as well. So if you wanted to add a column, pain level, by default it shows up as null. Like we go and take a look at it to see like, oh, this thing makes all of them null. Why are all these new null? Like, why is it the value of null in every column? And make them come to the conclusion of, well, you didn't tell it anything else. Like that's all the database has to go on. There's no way that you can just assume that it's a 0 or something like that. But there is a way that you can tell it, and that's by using the default keyword. So, yeah, like I'll do this for you, Adam, because why not, right? So you can see it too, because you're learning SQL stuff. So let's go ahead and make our new table that is called injuries, and then we're going to insert a whole bunch of stuff into it. And hopefully this works. Okay. And everything here is lowercase, so we don't have to put quotes around everything. So if I do select splat from injuries and run that, then I can see all my injuries coming back. Now, if I wanted to alter my injuries table, and you can say alter injuries, or alter table injuries, my bad. Yep, alter table injuries. So you have to tell it what you want to alter. And then you would say add column, and then a new column like pain level, and its type. So we say pain level is an integer. We run that, and then our alter table gives us a nice green back. So now if we go back to our select splat from injuries, we run that, all of our pain levels are null, which is, yep. And likewise, we can get rid of it. Alter table. Change a column name? Yeah. So rename column pain level to ouch. Yeah. So I think it's like that. Column 2, is it? There it is. Yeah. Not too often, but I run through that. But yes, so rename column pain level to ouchiness. That will do it. And then if we select splat from injuries, and now it is ouchiness. And we can say also that we want to alter our table injuries again, and we can say like alter. Let's say we wanted to set everything to 0. So one simple way, like I guess I don't get too much into null constraints just yet. That comes later. But alter table injuries. The other thing you can do is drop column ouchiness. So run that, then my ouchiness is gone. But I can add a column of ouchiness. It's an integer, and I can default it to 0. If I run that now, and I select splat from injuries and execute it, now my ouchiness, everything is 0, including. I think so. So if I have select splat from injuries and select splat from artist, and so if I have that and run it, then it should get me both of them. But if I just select that, then yeah, it will do that. Yeah, it's true. I noticed myself typing it over, and sometimes I'll go to the lengths of like, yes, this is definitely breaking out of the flow of normal. But it is true. Like I've tried to start doing like at least commenting more. So if I go and highlight this and then I run it, yep. So, yeah, I'll have to do that. But I at least have started trying to do the comment thing more. The whole command / thing, it works here as well. It works in most cases. That like it works on both here and inside of Chinook. Like that's also supported there. So I will actually try and do that a little bit more, because you're right. It is a little bit confusing. Or like the other thing that's nice about it is keeping around the context. So if they missed what you said before, one behavior I have noticed that students will do is not recognizing it's not like JavaScript code where you have to keep all your code around. And so they will continually write code and then never delete it. And which becomes problematic when we do inserts and stuff. Oh, like what a select is. Mm. Yeah, and that. Yeah, I do. Being immutable or idempotent. Yeah. I mean, I guess idempotent is even like it may not even be the right thing first. It's kind of an out there term. Like it's not doesn't ring bells for most people. But secondly, like idempotent can indicate that something will make changes. It just will not continue to make changes after you do it the first time. So you can keep making that same request or that same behavior, and it will only happen as if it were once. So idempotent doesn't mean that it's non-mutating or safe. But I do bring up with them specifically that when we do any command that's starting with a select is not making modifications to your database. So if you, for example, are doing a join, because I often get asked with joins, is this putting my tables together permanently? And I have to remind them that no, it's just doing it for the life of this query, or like it's doing it only so. Yeah, it's not actually combining your data. It's I know you've done some work with it, but I Gotcha. So Alright, so altering tables, real quick. So I've mentioned that drop columns not implemented in SQLite, which is a little bit jarring at first, but their workaround is that you go and you create a new table with all of the columns that you do want, minus the one that, like, with all the columns minus the one that you don't want to have. And then you select, then you go and you select everything from the original table back into the new table. Yep. Yeah, it would be similar to that. You rename the old table and you rename the new table to what the old table was. Alter table in SQLite. I don't spend a lot of time on it. Yep. Yeah, this could actually be something I drop. Part of it, like I used to do more of it inside the Chinook, but I've since moved to doing it inside of Postgres with them. So my SQLite subnodes, I should probably just kill that. I mean, it's important, but it's also like you'll figure it out. Like you'll see what it doesn't have when you go to, because most likely they're going to be using Postgres for their projects. So it's yet another thing that I should probably cut content-wise, because yeah, I do bring that up on this slide. So that SQL is one language, any relational database. and that dialects vary. So yeah. So I'd make it a point. So I mean, I guess there is the value in it, and I really don't spend a lot of time on how to do it in SQLite because it's not that valuable to explain how it happens. But I'll just say, like, instead SQLite expects you to create a new table with the columns that you want. Like I don't go walk through like the entire flow because that's not that vital. Talk about deleting and deleting a table. Drop table does that. And easy, yeah. And it also is a point where I will go and make a mention of backups and that they should do them. Yeah. And yeah. I guess I don't know. We're developers. Just do what I say. And likewise with deleting rows, like I bring up the caveat of like, if you only are just doing delete from injuries and you're not doing, like if you don't have a where clause, it will gladly go and just delete everything in your table. Yes. Yeah, I bring up the example of like, let's say you were going and you're writing a delete clause of like, yeah, delete from injuries, and then, or I think I'd do it with update instead, because delete is pretty obvious that you're not making any other things. But like if you have like update injuries set time to heal equals 12, and then your coworker taps you on the shoulder to go and show you some cool YouTube video, and then you get back to your desk and you say, oh, I was writing an update query, that's right, this looks good, and then you execute it, and then every table is updated, or like every row is updated, and there's no undo, there's no recycle bin or trash can, and instead like you need to revert from a backup. It's like, you did make a backup, right? And then I have a little anecdote about actually saving my company by restoring a backup. So I once came into work and had a coworker kind of look at me with this like terrified look in his face, and he had like deleted, I think it was our whole customer table. And what had happened is he was thinking that he was in our staging environment, and he was trying to change that, and he was actually in production. And yeah, the whole thing was gone, and I had this sinking feeling in my stomach of like, I hope our backups work. Cause like it's not the time. And luckily it did, but like I had this thought of like, that really could have been like the end of our company right there. Yeah, it was really bad. And so I was like, let that be a lesson to you that like they're very raw tools. It's definitely a different realm. It's true, like you don't have to worry about servers and stuff and like data integrity, like, because I mean you have to make sure that the data gets stored and it continues to be consistent even through like solar radiation and all that stuff. Like that's like, those are your problems. I mean, as a front end dev, like you can, like you have your own set of problems though, is that you have like a whole malicious world of people up against you. So like it's less like a mistake thing and more of like you are a pretty large attack surface. Not that databases aren't, but usually they have some safeguards in front of them. But like if you go and you forget to escape some HTML field, like your site can totally get rocked. Like I mean, like those are the things that we have to concern ourselves with a bit. And we put safeguards in place. Like we try not to go and like stringified HTML, like or like slap HTML straight on the page. And when you are actually building out a production database, like you build out accounts with certain privileges on them. Like your application, like the credentials that you give out to applications probably don't need rights to go and like drop a table or like alter table, like any schema modifications, like those definitely don't need to happen. And like sure, like if that's how you want to roll, good luck. And I know like some systems will do things like that, but yeah. Well, like if you think about something like Salesforce, for example, when you go in, have you used Salesforce before? Okay, well, it's basically just a database with a salesy UI on top of it. Like, I mean, well, I mean, you can run straight up database queries on it. Like you can write a SQL-esque type stuff directly against it. So it's far more exposed than anywhere else or than many other places. And with that, like when you sign up, like I mean, you basically get a database of your own, and trying to have a database of databases seems like it would be kind of a tricky problem versus going and like just creating a new separate database for them to run in. So like I could see some particular cases for it, but even then, like you don't really want your application doing that. You would more probably want your application to be able to queue some event that says, hey, go do this thing, and like maybe some like worker or something that goes and has only that right to go and like create new ones. No, like worker, no. Yeah, yeah, we're having scaling issues. Yeah, but that is fine with me. Yeah. Yeah, thanks for getting me in the mindset. Like I know I didn't cover all my slides, but I have a pretty good idea on my material of it. I would say you should go and check them out, and like if you are interested in it. So just as like github.com, if you look at my username, just statianzo/SQL course, in there you can get my slides and look at the so you can walk through all of those, and like I talk about constraints and modeling a little bit more towards the end, just to get like, now that students have been able to go and like read from databases, like create and alter them a little bit, now it's like, okay, how do I model this like many-to-one relationship? And so I talk a little bit about that, because you have to know some of it in order to make a database that is reasonable. So all right, have a good night, Adam. And I will go ahead and, I guess stream starting soon is probably not the right one, but yeah, I can show the padlock, I guess. So that is it for tonight. I don't have an ending stream type picture. Maybe I need one of those things, but it was fun working through it with you, Adam.